In section 4.3, we learned that triangles can be congruent, which means that all three of their sides and all three of their angles would match up. So if you look at the picture with the red markings on it, those two triangles are exactly the same. So that a set of congruent triangles means they're identical, okay? So let me highlight the congruent statement. What I've just highlighted in yellow is called the congruent statement. Again, this is something we've already learned in section 4.3. And the order of the letters tells you how the parts match up. So remember, I keep numbering these as position 1, 2, and 3. And then on the other side, you have position 1, 2, and 3. And so if you look at the congruent statement, you can talk about how the parts match up. Or you could look at the picture and look at the markings. You could do it either way. So let's list the angles first. And again, this is stuff we've already done in section 4.3. If we talk about the angles first, if you look at the picture, angle I and angle K both have single markings on them. So we're going to say that angle I is congruent to angle K. Also notice if you were going to look at the congruent statement instead, they're both in the first position, right? I is in the first position on the left side of the congruent symbol, and K is in the first position on the right. We could do that with the other two angles too. Angle J is going to be congruent to angle W, because in the picture they both have double markings, and in the congruent statement they're both in the second spot. And then we could do it with angle K. Angle K is going to be congruent to angle X. Again, for the same reason. They both have triple markings on them, and they're both in the third spot in the congruent statement. If we move over to the sides instead, let's do that with the sides instead. We're going to talk about IJ first. Let's talk about IJ first. It has a single tick mark on it. Right? If you look at it, it has a single tick mark on it. And if you go to the other triangle, so does KW. And so IJ must be congruent to KW because of the way they're marked. Or you could look at the congruent statement and say I and J are in the first two spots, and so are K and W. And we could do this with the remaining sides. We could say JK is congruent to WX because they both have double markings on them and they're in the second and third position in our congruent statement. And finally, we could say that IK is congruent to KX because they both have triple markings on them and they're in the first and third position in our congruent statement. So this is all stuff we learned in section 4.3. Now that's a total of 6 parts, right? You've got 3 angles that are congruent, and you have 3 sides that are congruent. And so we know that the triangles are exactly the same size because their 3 angles are the same in each triangle, and so are their 3 sides. Now what's new in section 4.4 is we're going to learn that you really don't have to prove that all 6 parts are congruent. You do not have to prove that to show that the triangles are congruent. You can actually take some shortcuts. So what we're learning in section 4.4 are those shortcuts. Instead of listing all 6 parts, we could actually talk about only 3 of the parts. So if we look at these theorems in this box section in the middle, there are 4 theorems. There's one called SSS. What that stands for is that all 3 sides in both triangles are congruent. And you might say, wait a minute, but what about the angles, right? Aren't we supposed to prove the angles? Well, some mathematician before us figured out that if the 3 sides are congruent, then the angles are automatically also going to be congruent. So as long as you know that the 3 sides are, then the 3 angles will match up anyway, so you don't have to bother talking about them. So that's why it's called a shortcut. There's another theorem, though. This one's called SAS. That stands for side, angle, side. What that's saying is if you have 2 sides and an included angle that are congruent in both triangles, then the triangles are exactly the same size. So again, you've only talked about 2 of the sides and 1 of the angles. You've only talked about 3 of the parts. What about the other 3 parts? What about, because there's a total of 6 parts. Again, that's why this is called a shortcut. We know if those 3 parts match up, then the other 3 parts will automatically match up. So we can take that shortcut. Let's talk about what an included angle is, though. What the heck's an included angle? If you come down below, an included angle is an angle that is between 2 tick marks. So if you look at the picture, let me pick a different color. If we look at the picture, you're going to see that we have an angle. Angle A is marked. And that angle actually lies between a double tick mark and a single tick mark. The sides that have the tick marks on them are actually making angle A. And that's what we call an included angle. So look for an angle that is right between two tick marks. So that arc mark's right between those two tick marks, and that's called an included angle. All right, another theorem says that if we have an angle, a side, and an angle, and in this case that means two angles and the included side are congruent. Let's talk about that word included again. Included sides are sides that are between two arc marks. So if you look at this tick mark that's marking our side, notice how it's right between these two arc marks. That's what makes it what's called an included side. We could also have a theorem that says, well, what if you have two angles and a non-included side? That would also prove that your triangles are congruent. So it says two angles and a non-included side are congruent in each triangle, then both triangles are exactly the same size. And hopefully you kind of figure it out. If an included side is a side that is between two tick marks, then a non-included side is a side that is not between two tick marks. So notice how the tick mark in this last picture on both triangles, look at this little single tick mark. It is not right between these two arc marks, right? If you look at that tick mark, it's marking side AC. Well, there's an arc mark on A, but not on C. That makes it what's called a non-included side, all right? And that might sound picky, included sides versus non-included side, but again, the letters are stated in an order, right? The S's and A's are actually stated in a particular order. So notice how the S is in the middle of this theorem, but the S is on the end in this theorem. And that's important because we're trying to show, by putting the S in the middle of the two A's, we're trying to show that it's what's called an included side. And in the last theorem, we're putting that S outside of the two A's. That means we're trying to show that it's a non-included side. So it is important that you state the letters in the right order and you get it matched up correctly. All right, so those are our four theorems we're going to be working with. And let's work on some examples, like what exactly will you be doing? All right, so in example 1, it says state which theorem could be used to show that the triangles are congruent. We're trying to show in example 1a that those two triangles are exactly the same size. And I can see that I have a bunch of tick marks on both triangles, right? I have a single tick mark on one side. Remember that tick marks mark sides, right? Arc marks mark angles and tick marks mark sides. And so I'm going to put an S on this one because it's marking a side, and I know it's exactly the same as this side that I just put an S on. They've also marked another side. They've marked one with a double, and they've marked this triangle with a double. So they've marked a second side. And they've also marked a third side with the triple marking. So what they've done in these two triangles is they've marked all three sides. And if you put the S's on the picture, and in the next example we'll be putting some A's, but in this picture we're only putting S's because only sides have been marked. And if you go back to the theorem and say, well, which theorem did I just mark up? I just used three S's in a row, right, on both triangles. And so you have they are trying to show you with the side theorem that the two triangles are congruent. So if I'm asking you which theorem, you would simply state the SSS theorem. That stands for the side theorem, okay? Since all three sides in one triangle are congruent to all three sides in the other, that means the triangles are exactly the same size. Sorry, I keep getting those words mixed up. All right, let's try it again. In picture B, I see that they've put some arc marks and one tick mark. So they have marked one of the sides with the tick mark, right? So sides are always marked with tick marks. They did mark one of the sides. But they've marked some angles too. So notice what they did. They put a single arc mark on one triangle and a single arc mark on the other. And so arc mark A stands for arc mark, but it also stands for angle. Then they've marked a second angle, right? They have an A here, and they marked an A in that next one. And so what have you put on each triangle? You've put two A's and an S. So if we go back up to our theorems, which theorems have two A's and an S? The theorem that has two A's and an S are this one that I've starred and this one that I've starred. And remember I told you a minute ago that it matters where the S is. In our picture, is that an included side or a non-included side? Well, that's a non-included side because it didn't land between the two S's, right? That tick mark did not, that didn't land between the two A's. So our tick mark did not land here. If it landed here, it would be ASA. But since the tick mark that they used was not there, it was outside of the A's, this is an AAS theorem being illustrated in these two triangles. We have two A's and an S marked in each triangle, and the S is outside of the A's. It's not right between them. So that's going to be the AAS theorem. All right, and C, let's do that same thing. What you're going to do every time is you're going to put the A's and S's right on your triangles, and then you're going to ask yourself, which theorem did I mark in both triangles? And both triangles are going to be the same. So sometimes I tell students, well, just mark one triangle with the A's and S's because the other triangle is going to be identical. You don't really have to mark them both. So it's up to you. You can mark them both or you could just mark one. I'm going to continue to mark both of them, but you're going to notice how both of them have the exact same markings on them. All right. So in C, I see they put a single arc mark. So they marked one of the angles. They put some tick marks. So they marked one of the sides. And then they marked another set of angles. So again, in each triangle, there's two A's and an S. And so that matches up to this theorem here. We have two A's and an S. However, oops, no, I'm wrong. That S is right between them. Sorry, that actually matches up to our third one right here. Our tick mark ended up being between our two arc marks. So in this picture, we have ASA, the theorem being illustrated. All right. And again, remember what we're really doing here. We're using the shortcut. We're just picking 3 of the parts and noticing how they're congruent, which even though a triangle has 6 parts total, we get to ignore the other 3 parts because by default, they're also going to be congruent. All right, finally, the last theorem, the last picture has a set of sides, right? Remember, tick marks are for sides. It has an arc mark. Oops, I forgot the other one. It has a side. It has an arc mark, which is an angle, and it has another side on each one. And so this theorem is the SAS theorem. That angle is right between the two sides, and the only one that has 2 S's and an A is the SAS. Okay, so that would be the only one you could have picked. So if you put the A's and S's right on your picture, pretty much the theorem is spelled out for you on each triangle. You can just basically read it off of each triangle. All right, but let's talk about a couple problems that make it a little bit more difficult. So it says if only 2 sides and angles are marked, then look for vertical angles or shared sides. Let's see what that means. So notice in example 1, there were 3 markings on each triangle. There were either, a combination of tick marks and arc marks, but 3 things were marked in each triangle in example 1. In example 2, notice how there's only 2 markings in each triangle. But also notice how these triangles are actually meeting up with each other. Notice in example 1, all the triangles were completely separate from each other. But in example 2, do you see how they're touching each other, right? So in example 2A, you should be looking for either vertical angles or shared sides. And so this triangle here, remember what happens when we have vertical angles. This set of triangles in example 2A has some vertical angles. Vertical angles, you're always looking for that X, right? I see an X happening right here. That means I have a set of vertical angles happening in this triangle. So I'm going to add the third marking because I know vertical angles are always congruent. I learned that way back in chapter 1, right? So I'm going to add the markings that are not on here, the third set. So if the third set of markings aren't on there, you can mark them as long as you know something that's congruent. I know vertical angles are congruent, so I'm going to mark them. And now I'm going to put my A's and S's on the picture just like I did in example 1. So an angle is marked in the top picture. It's also marked in the bottom. a tick mark on my side, a tick mark on my bottom triangle side, and then I marked this extra set of vertical angles, right? So I got to mark an extra set of angles. And so if you look at both triangles, the theorem that's being illustrated is ASA. That S is right between the two A's. All right, let's go to example 2B. Example 2B, again, I have two triangles, and notice this set of triangles is meeting up. If I trace them, let me trace one of them in purple. And if I trace the other one in red, notice how the red line and the purple line are right next to each other. Basically, they're right on top of each other if I would have drawn that a little bit better. So the purple triangle and the red triangle actually share a side. And the side they share is this one right here. And so I'm just going to put an S on there because they're sharing that side. So obviously, if you're sharing a side, it must be congruent. You have the same side that you're sharing. It's the same size then, right? And so any shared sides that you see get marked with an S. Let's see what else is marked. They also put a single tick mark on that triangle and then a single tick mark on the other, and then they put a double and another double. So in each triangle, if you looked at each triangle, you have three sides that were marked. So this is the SSS theorem. All right, two more. Let's do two more. So hopefully what you notice about example 1A is that you have an X, and sometimes I say these are bow tie problems. You actually have two triangles that have an X in them. It's going to kind of look like a bow tie. So I don't know if you see that, but that's what I see when I look at example 2A. That's the same thing I see when I look at example 2C. I see a bow tie. And so when you see a bow tie, or again, this X that's happening in the middle, you know you have vertical angles and you get to mark them. So I'm going to mark them. Actually, I could use a single marking if I want. You can use any kind of marking you want, but I'm going to use a single marking there. Okay. So even though there were only two markings in each triangle, I'm able to add the third one in because I know this theorem from chapter 1 that says vertical angles are congruent. So now let's see what I marked. I have a double tick mark on each triangle. I ended up putting an angle marking on each triangle, and I have a triple marking on each triangle. So if you focus on one triangle at a time, you really only have, like I said, you really could just be marking one. So let me focus on these that I'm highlighting in yellow. Those are on that left-sided triangle. So I have marked an S, an A, and an S. All right. All right, finally in example D, this looks just like example B. They're meeting up and sharing a side. And so that middle piece that both of them are meeting up at, that's called a shared side. So I got to put an S on the triangle already. They're sharing that side. Let's see what else was marked. They put a single marking on one triangle and a single marking on the other. They put a double angle mark and then another double angle mark. So again, if you focus just on one of the triangles, you have an A, and an S marked. And that S did not land between the two A's. If it had landed between them, it would have been right here. But since it didn't land between them, it landed outside of them. Remember that theorem is called the angle side because that side is not what's called an included angle. It's a non-included side, not an included side. So that's the AAS theorem. All right? So in this section, what you should be doing is putting your S's on your tick marks, your A's on your arc marks, and then looking at which theorem did you actually mark in each triangle.